Hello my lovelies, it's Susanne, and today I want to show you how to solve this problem. 3 identical circles with a diameter of 2 meters touch each other. We can see our 3 circles here with a diameter of 2 meters, and they touch each other here, here, and here. How long is the red rope that runs around the outside of the 3 circles? We have to find the length of this rope here, and I call the length L, and we can divide this into this straight line here, then we have another straight line here, and another straight line here. So we need to find the length of these green parts, plus then we have this circular arc here, the circular arc here, and here as well. So we have to find the lengths of these orange parts. Okay, what do we know here? We know the diameter of our circles, and then we also know the radius of our circles. So if the diameter is 2, half of it is 1, which is the radius of our circle. Okay, then usually these touching points are really important to solve problems like this. And that's why I want to draw the radius here from the center to this touching point as well, which is radius 1. The same here to this touching point, it's also my radius. The same here, which is my radius, and on this side here as well to this touching point, I have radius 1, radius 1. Now I created a triangle here, but the question is, why is this actually a triangle? Why is this a straight line, although it consists of this part and this part? Well, this is a straight line because these circles touch each other at this point. If we want to draw the tangent line at this point, then this is the tangent line to the left circle. It touches my circle at this point, and it is also the tangent line of my right circle because it also touches my right circle at this point. And we always know that the tangent line is always perpendicular to my radius at this touching point. So my tangent line is also here perpendicular to this radius here at my touching point. And if I have a 90-degree angle here and here, that gives me a 180-degree angle here in between, so this is a straight line. Okay, so now we know that this is a straight line. Same explanation, this is a straight line, and this is a straight line as well, so this is a triangle. What about the lengths of the sides of my triangle? I have 1 plus 1, which gives me 2 here. 1 plus 1 here as well, which gives me still 2. And here I also have length 2, so this is an equilateral triangle. And what do we know about equilateral triangles? We can say something about the angles. So we know that all 3 angles have to have the same size. All 3 angles in a triangle have to be 180 degrees in total. If all 3 of them have to have the same size, I can just divide this by 3, which gives me 60 degrees for each angle. So here, here, and also here. Okay, I'm just collecting information here. I don't know if we can use it, but the more we know about our situation here, the better. We were actually interested in the lengths of these green lines here. So maybe we go back here again. And it also looks like as if this green part has the same length as this part here, which would be 2. Is that true? Can we prove this? Well, we have another touching point here. We know these points are important, so maybe we use them. If I draw the radius here as well from the center to this touching point, I have radius 1 here. And we now know that the radius is always perpendicular to the tangent line. And this is a tangent line because it touches my circle here. The same thing on the other side. I can use this touching point. I draw the radius, radius 1, and it is perpendicular to this tangent line here as well. So I have a 90-degree angle here, 90 degrees here as well. This side and this side, they have the same length, so they are parallel as well, which means that I have to have a 90 degrees angle here as well and here as well, which gives me a rectangle, which tells me that this side has to have the same length as this side, so it is of length 2. Because everything is symmetric here, we know that this green part has length 2, same part or same length here then as well, and here as well for these green parts. So the length of my green parts, 2 plus 2 plus 2 equals 6. So now only the orange parts are missing. So I need the length of this circular arc. I can find it if I know this angle here. So my orange part goes from here down to here. So if I had this angle here in between, I could find the length of this circular arc. Do I know this angle? Well, not yet, but we can calculate it because we know this is a 90-degree angle, 60 degrees here. What about this angle here? This is part of the same rectangle we created here, so we could draw the same rectangle with the green line here so that we know that this is a 90 degrees angle again. So in total, all 4 angles together have to be a full circle, so 360 degrees. So far, we have 90 degrees plus 90 degrees equals 180 degrees, plus the 60 degrees here gives us 240 degrees. To get from here to here, we need an additional 120 degrees angle here for our circular arc. The same thing we have down here and up here as well. So we have an angle of 120 degrees here as well. And the same here with the orange part. From here, this angle is also 120 degrees. So I could start now and calculate the length of this part here with the 120 degrees, or I can be a little bit smarter and take a look at all 3 of these parts together, because I have 120 degrees here, plus 120 degrees here, plus 120 degrees here, which gives me a total of 360 degrees. So if I put all of these arcs together, I get a full circle. and I just need the length of the circumference of the circle. I don't need to use these arcs. I can just use a full circle. This is going to be the length of my orange parts together. So, what is the circumference of a circle? The formula is c equals 2 pi times the radius of my circle. The radius of my circle here is of length 1, which is nice because then we have times 1 here. Times 1, we don't need this. We have 2 pi as the length of our orange part, so we put it in here. This is the length of my rope, but if you want to calculate it, just type it in your calculator and we get a result of 12.28 meters for the length of our rope. I'm curious how you solved this problem, so please let me know in the comments. I wish you a wonderful day and I hope to see you in one of my next videos. Take care!